Now that we've talked about what readers' writer locks are in general, and I've given you an overview of some of their pros and cons, we're going to start diving into the details of the Java ReentrantReadWriteLock class. What we're going to do in this part of the lesson is understand the structure and functionality of this class. The Java ReentrantReadWriteLock class provides a Java readers' writer lock implementation. It implements the read-write-lock interface, which is part of the Java util concurrent locks package. It also contains nested readLock and WriteLock classes that implement the lock interface, which is also defined in the Java util concurrent locks package. The Java ReentrantReadWriteLock implements readers' writer semantics. What that means, of course, as shown in this picture, is that multiple reader threads can run concurrently within a critical section, only providing readout access to the state of the object. In contrast, only one writer thread can run in the critical section at a time. And so the readers' writer protocol is used to ensure that the waiting readers queue up when there's a writer, as well as other writers queue up when there's a writer. But as we see here, when there's only readers, then many readers can go in. And likewise, writers will queue up, waiting for the readers to finish. ReentrantReadWriteLock has so-called pessimistic semantics. What that means is that the locking mechanisms assume that contention may occur. Internally, the Java ReentrantReadWriteLock class applies the bridge pattern. And I'm sure you're familiar with the bridge pattern by now. It's basically used to decouple the interface from the implementation, such that in this case, fair and non-fair readers' writer semantics can be supported in a uniform manner. And this is very consistent with other uses of this we've seen. Internally, the locking protocol is handled by the sync implementer hierarchy. This sync implementer hierarchy inherits functionality from the abstract queued synchronizer framework. This framework, as we've talked about before, is used by other Java synchronizers that require first-in, first-out wait queues. You can also see how it has a pair of non-fair sync and fair sync subclasses from sync that provide the non-FIFO and FIFO semantics, first-in, first-out semantics, for this lock. The constructor of ReentrantReadWriteLock enables a choice between fair versus non-fair lock acquisition models. And these models apply the same basic pattern, the bridge pattern that's used by the ReentrantLock and the semaphore that we talked about in earlier lessons. In particular, this constructor takes a parameter called fair, and this parameter determines whether the fair sync or non-fair sync semantics are used for the class. If fair sync is selected, if the Boolean is fair, as if that's true, that ensures strict first-in, first-out fairness, which gives you fairness at the expense of some performance, as we talked about before. Conversely, the non-fair sync semantics, which can be selected if the fair parameter is false, enable faster performance at the expense of fairness. So you have to decide which approach you really want. In general, fair sync is a lot slower than non-fair sync, so use it accordingly. It's also worth noting that by default, if there's another constructor that has no parameters, and by default, the behavior is non-fair sync to emphasize performance over fairness. The constructor also goes a little further and initializes the reader lock and writer lock fields. Write lock and read lock, which are the types that these fields are based on, use the shared mode of the abstract queued synchronizer framework. And so that means that you can have multiple readers going simultaneously, but of course only one writer at a time. And as I mentioned before, write lock and read lock implement the lock interface. So they end up with methods like lock, unlock, try lock, and so on, that we've talked about earlier when we discussed the other locking mechanism, Java ReentrantLock. So that's the end of the overview of the structure and functionality in the Java ReentrantReadWriteLock class.